Hi, in this video we'll be discussing important information on Martin lighting general troubleshooting. Troubleshooting is important in order to quickly identify and replace broken components and keep product turnaround time at a minimum. If applicable, this video can be accompanied by product-specific troubleshooting guides for the technician to perform product-specific troubleshooting techniques. As a general rule, divide and conquer the fault finding by dividing it into two parts. Figure 1 shows all components of the flashlight, which you must determine how to divide those components into two sections and start troubleshooting one section. Figure 2 shows the reduced components after dividing the flashlight into two sections and focusing on one section. Prior to taking a measurement, use the multimeter to check for continuity or continuous connection between the wires and the switch to ensure that there are no breaks in the connections. Now, a measurement can be taken with the multimeter to determine if there's any voltage from the batteries. If the batteries have voltage, then move on to the next part in that same section and divide it into two parts to find the fault. To find a fault with a fixture, it's best to start halfway. Take a measurement from the input of the igniter to determine if the ballast is providing enough power for the igniter. Do not measure the output of the igniter. On many fixtures, you may not be able to access the igniter to measure from the input. So in this case, it is best to measure the output of the ballast directly from the ballast. To continue the flashlight troubleshooting example, after further dividing the next section into two for testing to find the fault, take a measurement for the voltage between the wire near the batteries to the lamp with the switch on, as in Figure 3. If no voltage is measured, then divide the parts further and measure for voltage between the wire near the batteries and the switch, as in Figure 4 to determine if the switch is the faulty component. If Mac fixtures present an effect problem, an error could occur on the sensor side or the actuator side. Utilizing the divide and conquer troubleshooting format, start with the actuator, or what's also known as the drive side. If it works correctly, then move to the sensor side. In most cases, if it's the sensor side at fault, then the mechanical side will continue to work, but may present some abnormal behavior, such as the fixture hitting its end stop. End stop normally deals with a mechanical end stop, which does not use a sensor. However, effects such as focus and zoom do have an end stop that normally uses a sensor. Many of the current fixtures are very good at troubleshooting and display an error code to help determine the problem. With an understanding of the few basic components that exist in the mechanical effects of Mac and other fixtures, a technician will be able to troubleshoot thoroughly. In the actuator section of a fixture, there are several components to check when troubleshooting. The motor drive circuitry, shown as 1 in the figure, is used to create motor pulses, where 4 outputs are normally used. Part number 2, the onboard connector, should be checked for corrosion causing bad connections. With newer fixtures, it's rare to find dry solder joints, but older Mac 250 and 700 range products did suffer from dry solder joint problems and should be checked. For verifying part number 3 in the figure, wire checks should be done visually and with your fingertip to ensure good continuity and connection. Ensure the connector and pins on the stepper motor, denoted as part number 4, have good contact and that there are no bent pins. Check the two coils inside part 5, the stepper motor, because the resistance of the coils varies from motor to motor, and the resistance of the two coils should be the same. The best way to verify this is to measure between pins 1 and 3 and pins 2 and 4 for resistance comparison. If the measurements differ greatly, or one is either open or shorted, the motor must be replaced. Check part 6, the set screw, which on some fixtures has a D shape where it is necessary to make sure it is on the flat spot. This part ensures the mechanical effect has a good grip on the motor axle. The actuator allows the sensor circuitry to determine the position of the effect. For the 7th, verify the actuator or magnet is present. Otherwise, when it passes the sensor, it won't detect anything. Checking the magnets is always important when looking at gobo and color wheels, or anything that's going to pull across a sensor. Also, check the distance between the actuator or magnet and the sensor to ensure they are the correct distance apart, so that when the magnet is passed under the sensor, it actually detects it. Depending on the type of sensor, there are different things to look for when there are different types of sensors. Mechanical sensors are typically easier to check than electrical sensors. A sensor LED can be used in troubleshooting to identify the state in 3 different modes. Verify the sensor is not powered if the LED is not illuminated. If the LED is green, the sensor is powered on. The color amber designates the sensor is sensing the actuator. Check for corrosion and that the condition of the plastic is good on the onboard connector. Visually inspect the wire from the motor driver onboard connector to the sensor board for any cuts or bends in the wire and terminals for good connection. Check the sensor circuitry is clear of any residue, free of cold solders, and breaks or bends on the component pins. To understand the process of simplifying troubleshooting, let's review Troubleshooting Example 1. A technician receives a Mac Viper performance from a customer with the error description C1ER in the display. The technician looks up the display message in the user manual. What are the facts that were provided or found? C1ER is shown on the display. No other errors are displayed. What is determined after further investigation? After looking at the troubleshooting checklist, it is believed the error has to do with the effect errors. Therefore, it is decided to turn on the light. After the light has reset, it reports C1ER on the display. As C1ER is the only error being reported, the technician concludes that the cause of the error is in the mechanical effects section of color wheel 1. How does the technician proceed with troubleshooting the error? The technician uses the manual menu to change the position of the color wheel, which seems to be working fine. The tech also verifies that the holding torque of the motor is high by gently pushing the color wheel back and forth. The belt tension is also fine. Finally, the technician checks that the sensor LED on the sensor board changes color from green to amber while rotating the color wheel. However, it is discovered that the sensor LED is not green, which means it is not powered by the sensor circuitry. The tech then realizes that there is an error that needs to be fixed at the sensor side, and therefore does not need to use any more time on the actuator side. How does the technician resolve the issue? Looking at the sensor side, it is quickly determined that the color wheel sensor connector is not connected properly. The technician fixes it, resets the fixture, and the error disappears. Notice how the technician quickly determines what side to look for the problem and only focuses on the section where the problem is. This is a good example of the divide and conquer troubleshooting process. Let's review another example of troubleshooting. A technician receives a Mac Quantum wash from a customer with the error description no light output. When the tech powers up the fixture and the reset is done, the display message SLER is reported. The user manual states, SLER safety loop circuit activated. A temperature circuit breaker has shut down the LEDs. Circuit breaker resets automatically after temperature has returned to normal operating range. What are the facts that have been provided or found? SLER is shown in the display. Light output has been disabled by the system. How does the technician proceed in troubleshooting the error? The tech turns off the fixture and allows it to discharge for 5 minutes. When the tech looks at the connection schematic, they see that the safety loop is monitored from C5-PL7 on board C, DC-DC board. It is decided to verify that the issue is in fact related to the safety loop. After disconnecting C5 and measuring the resistance between its 2 pins, the tech realizes that they are right. The technician measures the open circuit as the safety loop is broken somewhere. To find the place where the safety loop is broken, they check the PFC board. The tech measures a short circuit between the 2 PL6 pins on board B, which means the thermal switch is okay. The tech then checks the last thermal switch, which is located in the safety loop section in the head. The easiest way to measure the thermal switch is by disconnecting D11/PL10 on board D, which is the color engine board. The tech then measures a closed circuit between the 2 PL10 pins, which means the thermal switch in the head is okay. The technician now believes that the wires going from the base to the head are broken somewhere. To verify this, the tech places jumpers on B3 and D11 and measures the continuity between the 2 C5 pins. In this way, the tech measures the complete wire set only. There is no conductivity, and therefore the wire set is most likely broken somewhere. How does the technician resolve the issue? The tech opens the yoke and discovers that one of the safety loop wires is broken. They replace the wire and the fixture works again. Notice how the technician quickly determines what side to look for the problem and focuses only on that section where the problem is. This is another good example of the divide and conquer troubleshooting process. Let's review one final troubleshooting example. A Mac Quantum Wash is handed over to a service department. When the fixture is powered on, the display is blank, but it's permanently lit up. What are the facts that have been provided or found? The product is resetting. Pushing the base buttons does not change anything in the display. What does the technician determine after further investigation? The connection schematic indicates that the display is connected directly to the main board. How does the technician proceed in troubleshooting the error? As the product is resetting, the main CPU is running, which means that the problem is related to the display cable, or the display driver on the main board. The display cable looks fine and is properly connected. How does the technician resolve the issue? After replacing the display, the error is gone. The troubleshooting checklist provides identifiable symptoms that a technician should be able to recognize in order to resolve fixture and other electronic product issues, whether visually, through hearing, or smell. Is there power, whether high voltage or low voltage? Can something be heard? Is there an unusual smell? Are there any control issues? Is there erratic movement? Are there optical errors or lamp issues? In terms of display messages, are there communication errors displayed? Are there effect failures displayed? Are there calibration adjustment errors displayed? This concludes this service training. Thanks for watching, and we'll see you in the next one.